12.1 Surface areas of prisms. Here are a few vocabulary terms that you need to write down. Polyhedra, solids with flat surfaces. Prism. A prism would be a polyhedron that has two congruent parallel faces. So I'll draw a couple of those. So to draw these figures, if I wanted to do a triangular prism, I would do two triangles that look alike, and then I'm going to connect their corresponding vertices. And the two parallel faces that they're talking about would be right here and right here. These two congruent faces would also be known as the bases. The parallel edges joining the vertices of the bases are known as the lateral edges. So that would be right here, and then this dotted one in the back. The faces of the prism that are not bases would be the lateral faces. So that would be this right here, the one on the bottom, and there would be one more on the back side of this triangular prism. The lateral surface area is the sum of the areas of the lateral faces. So we need to find the area of each of these faces. I am actually going to start with this face on the bottom, which would be 14 times, that would be 20 because it's parallel to this edge, that lateral edge. So we would have 14 times 20, 280. Now the next one, we'd have to find another. I'll go in the back, the one in the back. So that would be 20 times 13. So when we multiply that, we get 260. And the last would be the one right here in front, which would be 20 times 15. And that would be 300. So the lateral surface area would be all three of these added together, which gives you a total of 840. This would be units squared because we're still dealing with area. For the total surface area, that would be the sum of the prism's lateral area and the area of the two bases. So we would need to figure out the area of the two bases and add it to 840. So the base were the two triangles like that, and we know that the base of the triangle is 14 and the height is 12. So to find the area of a triangle, it would be 1/2 base times height. So we would have 7 times 12, which would be 84. And because we have two bases, we would multiply 84 by 2 to get 168. And then to get our final area, the total surface area, we would have 840 plus the 168 for a total of 1,008 units squared, and that would be your total area. Section 12.2. It's the same information, only we're dealing with pyramids instead of prisms. So for a pyramid, you have your base, which can be a square, it could be a rectangle, it could be a triangle, and then there's not two bases because everything goes to a point. And to find the lateral area, you would add the flat faces that are not the base, and then there would be one in the back and there would be one more on this side. To get the total area, you would take your lateral area and then add your base to it. So that is a quick summary of 12.2. Otherwise, it's the same concepts from 12.1. The big difference is there's only one base, not two. 12.3 addresses the surface area of circular solids. So a right circular cylinder is a prism having two bases that are circles. The right circular cylinder means that if you have a line containing the centers of the bases, it is perpendicular to each of the circular bases. Now the lateral area of a cylinder is actually pretty neat. This right here is the lateral area, and you can think of if you had a can and you cut the side and you unrolled it, this right here would be the lateral area, because it would end up making a rectangle, because if you unroll it, this would be the figure you had attached to the two bases. So the lateral area would just be the height times this part right here, if we rolled the can back up, would be the circumference of the circle. So your lateral area would be the height of the cylinder and the circumference of one of the bases. Then you would find the area of the circle and add two of those to the lateral area to find your total area. So let's try it out. We have a cylinder, and to find the surface area, or I'm sorry, the lateral area, our height would be 12. I realize that it's on its side, so you might not think of that as the height, but that is the height. And then to find the other thing to multiply it, we need the circumference, which is 10 pi. To get the lateral area, we would multiply those two. Circumference of the circle times the height of the cylinder. So we have 12 times 10 pi, which equals 120 pi inches squared. The total area, we would have to add the lateral area to the area of the two bases. So the bases would be the area of a circle, which is pi r squared. So that would be, the radius would be 5 squared times pi. We have 25 pi. And because we have a base here and there would be another base over here, we'd multiply that by 2 to get 50 pi. Then to get your total surface area, you would end up adding that to your 120 pi for a total of 170 pi inches squared for your total area. So for the next one, we are not given the height, but we can find the height. If you look, you can draw a line from here to here, and that would be going into the middle of your cylinder, which would make your diagonal, instead of 10, we can think of it as 5 and 5. And this would be a special now because we made a right triangle. So this would be 4 centimeters, and the total height would be 8 centimeters. So the lateral surface area would be your height, which is 8, times the circumference, which would be, we're given the radius, so 2 pi r, which is 2 times pi times 3. So your circumference would be 6 pi. To get the lateral area, you just multiply those two together, 8 times 6 pi, and you get 48 pi inches squared. To get the total area, we need to find the area of the two bases. So we have one base right here and one base right here. So we would have area of circles, pi r squared. We have pi times 3 squared, which is 9 pi. Since we have two bases, that would be 18 pi. So the total area would be 48 pi plus 18 pi. We end up with 66 inches squared for the total area. Let's move on to cones. A cone resembles a pyramid, however, the base is going to be a circle. And the other difference is that in a pyramid, the slant height and the lateral edge are different. So in a cone, they're the same though. And we will go back to the pyramid and talk about that. Let's actually go back to that page. On your pyramid, your lateral edge would be right here. That would be your lateral edge. And the slant height would be right here. So the slant height is not an edge, it's actually part of the face. So that is your slant height. And to find the area of a face, since it's a triangle in this situation, we would need the height of this triangle. So you're going to need the slant height, and then you would need the base to find the area of that face. Another thing I wanted to point out is sometimes you may need to find from here, drop down. You might need to find the height of the pyramid. And in order to do that, if this was 10, then you would know from here to here is 5 because it's a right pyramid. And then if you had the slant height, you could, if this was, let's say 13, the slant height, then you would know the height of the pyramid would be 12 because there would be that triangle inside. All right, let's go back to cones. So the formula for the lateral surface area of a cone would be 1/2 the circumference times the slant height, which was represented by a cursive L, lowercase. So if you think about this, this has a simpler formula, but if we have the circumference, that's actually 1/2 times circumference could be 2 pi r. Well, half of 2, that cancels to 1, so we could write this as pi r and then the slant height, L. The surface area of a cone, the total surface area, would be your lateral area plus the area of the base. And in this case, that would be a circle. So let's try this out. Let's find the lateral area of the cone in example 1. So the lateral area is equal to pi times the radius of 9 times your slant height, which we don't have. So right now we have a 9, 12, and this is a 3, 4, 5. That's 3 times 3, 4 times 3, 5 times 3. So this slant height would be 15 inches. So let's plug that in there. So 15 times 9, we would end up with 135 pi, and then we would have inches squared. For the surface area, the total area, we're going to add the base. So the base area would be pi r squared. So we have pi times 9 squared, 81 pi. So we need to add 135 pi plus 81 pi. And you end up with 216 pi inches squared for your total surface area. Okay, so now let's find the total area of the figure to the right. So we have to think about this and what area means. If you're going to paint something, the surface area is if you're going to paint it, how much area do you need to paint? So the big thing you need to take away is usually with a cone we get the lateral area and then we add it to the base to get the total area. However, are we painting this part? The base, does that get painted? And the answer is no, that part doesn't get painted. So we need to not add that into our total surface area. And then when we analyze the bottom part, yep, we will paint the lateral area, which remember is the height times the circumference of that circle, and we will have to add in one of the bases on the bottom. So that's everything that would get painted in this figure. So let's start. For the cone piece, we would just need the lateral area of the cone, which is pi times the radius times the slant height. So we have pi times the radius, and that we need to still figure out. When you first look at the picture, you might not think you have enough information. What I'm going to concentrate on is I know from here to here is 13. And if I take that 13 and I take away this 8, 13 take away 8 would leave me with a height of 5 here. And then if I went from the center out, this would be a special, and from here to here it would be 12. So now we have enough information. So let's go back to the lateral area would be pi times the radius of 12 times your slant height of 13. And then we get 12 times 13 is 156 pi for the area of the lateral area of the cone. Now let's get the lateral area of our cylinder. the lateral area of the cylinder is just your height times the circumference. So your height is 8, and your circumference would be 24 pi. And when you do 8 times 24, you end up with 192 pi. And then the last bit that we would have to paint to get the total surface area would be this bottom base, which is a circle. So that area would be pi r squared. So we have pi times 12 squared, 144 pi. Let's add all those three pieces together. You get 156 pi plus 192 pi plus 144 pi. And your total area would be 492 pi centimeters squared. The last thing we need to talk about is a sphere. So a sphere would be a circle that's three-dimensional. It's like a basketball or a volleyball or a tennis ball. A hemisphere would be half of a sphere. The great circle, if you look at the picture to the right, the great circle would be this piece right here. So if you were to chop the sphere in half, either vertically or horizontally, it would be the diameter that would turn into the circle portion. So they have it here. If you were to slice it, this would be your great circle. The total surface area for a sphere is actually a pretty easy formula. It's equal, total area is 4 pi r squared. All right, so it asks, why does a sphere not have a lateral area? And when you think about it, remember, it's what we're going to paint. So if we're going to paint this whole outside, is there ever a base that we paint? And the answer is no, there's no base. So your total area and your lateral area would be the same, pretty much. So we're going to find the surface area of a sphere with a radius of 5. So for number 1, we have a radius equal to 5, and when we plug that into the formula, we have 4 times pi, so total area, 4 times pi times your radius squared. So we have 25 times 4, 100 pi, and they did not give us a unit, so we'll say units squared for number 1. For number 2, it says the surface area of a sphere is 256 pi inches squared, and this time we have to find the radius. So the total area is equal to 4 pi r squared. So we have 256 pi as the total area is equal to 4 pi. We don't know the radius. So to solve it, we're going to divide by 4 pi. The pi's cancel, and when you have 256 divided by 4, you get 64 is equal to r squared, and your answer is plus or minus 8. You can't have a negative 8, so 8 inches is your radius. And that concludes your notes for day 1, chapter 12.